Okay, there we go. Yeah. So bringing in the models, sometimes they're unitless, so there's no definite way to know what units they are. This one happened to have it where it showed it was in millimeters, but you don't always have that available. So the quick check was you have to use a little bit of common sense, a little bit of logic. Check the distance. Is that 319 inches across, or is that 319 millimeters? So came to conclusion that's in millimeters. And going from there, created blocks. So created a right block of just this because I need to know my whole distances. And then I needed my final view, which was going to be this one for the front view and this one for the top view. So again, the command was W block. That lets you write a new block. Choose the folder I'm going to save this in. Where is it? There we go. So I'm going to just name this something simple. Genset top. Genset top view. And then previously I had started off with a couple different views already, so I have my bottom, my front, and my top. So I've already done that from last time. So I will jump back over to here. So as you see, I've already gone ahead and done a few of it, but I can just go back to show you what I had done before. So bringing in the bottom, there's my bottom. This was something that I had already scaled. Had this not been scaled, it would be a lot larger, but the way to scale from millimeters to inch is using that 25.4 factor. So 1 divided by 25.4 gives me that scale factor I need to put in. I would punch that in after choosing a base point and scale it down. So I've already done that. This is now in an inch size. So I can continue on with my project. From there, I'd mentioned we want to be mounting this onto a 3 foot by 6 foot by 3 foot tall table using 2 by 2 by quarter HSS around at the corners and on the horizontal plane of the frame. So this is going to be 36. Sorry, other way around. This is going to be 22, 36, and there's my table. So I saw some of you guys taking measurements. That's one way to do this, to figure out your hole pattern. The other way you can actually do this is, since you already have the model, you don't have to do additional work. You can throw it down a Centerline for reference. Rotate this object so I have it in line like so. And I'd said I'd want to put this 12 inches from the back, so there's my mount plate, 12 inches from the back of the table. I'm going to move this from my reference point now, 12 inches. That's done. I can then draw in my hole pattern, matching circle for circle. Like so. There we go. So there's the plate of my table. So isn't that a little bit easier than taking the measurements and trying to locate everything? Try to use the model to your advantage, because you can't get any more accurate than that. In real life, this would be something they call a match drill, essentially, by having your object directly onto what you need to be mounting onto. It's essentially perfect, right? There's not much closer you can get to this. So once I have that, that's my top of my table. As you can see, did that previously. Just gonna delete that one. And then I projected a view to show the front view of it. The reason I did this is because later on, we're going to want to show thickness of this table. The only way to show thickness is you have to have multiple views so you can actually dimension it properly. And I did actually show this where my hole locations were. As you can see, they line right up with the holes above on a hidden line layer. So that's the top of my table. I then proceeded to make the rest of my table. So now that I had this made, I could copy that over and put that into view of this. The reason why I have multiples now, because as I mentioned, you need to have multiple views of things dependent on what kind of component they are. So if you were to truly build this, this is a standalone piece. This is something you would actually send out to a shop to have that plate cut down to the right size, and they would actually mark those holes and drill them out, either by a machine or put onto a cutting surface. So a laser, a water jet, a plasma table, something that would actually cut those holes out for you. So multiple ways of doing it. This is more the assembly side of things. So to actually get to the legs though, we have to actually build up that frame. So here's my frame. So essentially for this, to figure out my height, just went back and checked, 3 foot tall. So overall height needs to be 36 inches minus the height of, or the height of this HSS. So 2 inches there, leaving me with 34 inches left on the bottom. If you wanted to interpret this as taking the full height, including the 1/4 inch, which is I believe what I did, then this is actually just, 35 3/4. So to do this was literally just drawing out my lines for my vertical legs there, and across, and all the lines inside are just hidden lines of the internal hull tube. Finishing off my corners on a top view, I've mitered each of my corners. That's just a 45-degree line there. So in case we forgot how to do polar, I just did a 45. You can extend it past. You don't have to actually figure out the true distance of that, because I'm going to draw out that line, offset that by 2, because we're talking about inches here, and continuing on to this side, same thing, offset by 2. Oops. Like so. Do a fillet with a radius of 0. Trim that back. And I can trim this piece. And that's my top view with 2 mitered HSS beams put together. Down below is top-down view of my HSS. That can be done a few different ways. You can draw yourself a rectangle, 2 by 2. Two. Oh, where'd it go? Two by 2. There we go. Oh, what is going on? There we go. From there, we don't have perfect dimensions of the outside radius, but it's typically about a 1/4 inch. Like so. And then the wall thickness was 1/4 inch, so 0.25. In like that. Fill it again. Radius is about half, so 0.125. Switch over my layer, hidden, and then that's my top-down view. All right. So this is its own standalone drawing as well. I can add one more view if I want for the side view, like so. Trim that back, and there we go. This is my side view. So those are all the views you would need to build this specific table. Depending if you're required to do it, some companies will actually ask you to do an individual part drawing for each of the unique pieces of HSS. So again, I would just copy out just that piece that I need. Move that over, change that layer. And there you go. That would be my detail drawing of this piece here. Just because these have miters on them, and then you'd repeat it for this piece here for your shorter lengths. And we'll get to showing that on the annotations a little bit later. So there's my table. Here's my table fully assembled. As you notice, I've chosen to leave out hidden lines on my assembly of the table. That's just for clarity. There's times when you're going to need to choose whether to show all the detail, or certain times you can choose to actually hide away some detail just for clarity's sake. Because the detail of the thickness of the tubes and everything else was already done on this component drawing, meaning your full assembly can be left a little cleaner. All right, and moving on from that, that's my table. So, gonna jump onto generating the building itself. So we're gonna look for W12 by 79 wide flanges. So W12 by 79 right here. As I mentioned last time, if you ever need to, there's a nice handy tool called Snipping Tool in Windows. If you start that up, it will actually let you just go ahead and snap whatever you're looking at. And we'll go ahead and draw this up. So in case there was any confusion about how to read this, this is your steel callout. So this is the general name for this beam shape. After that, you follow through the rest of the columns. So area is not helpful for us right now, but the D is for our overall height, so 12.38. So I can draw my vertical 12.38 construction line. After that, we're jumping over to our BF, which is our flange width here, 12.08. Again, you can choose to do the math, or you can just punch everything in and let AutoCAD do it for you. And we've got TF, that's our thickness of the flanges here, 0.735. GW is going to be our web thickness, 0.47. Again, holding down Shift after I've chosen the Move command brings up our secondary snap menu. So again, to do that, choose my object, M for Move, enter that. Hold down Shift as you right click and bring this down your new snaps. You can find a midpoint between 2 points. Find that right there. So I've got my base point is between there. I have my construction line already, so I can snap that down right there. I know the height of this, so I'm just going to mirror this right here. There's my midpoint. Like so. To my fillets. Technically, let's do this now. Mirror all that. That's done. Actually, looks a little bit skinny. I'll make sure this is right. TW. 0.47. Okay, that's good. And if you want to make it look a little bit cosmetically closer to what it should be, you can go ahead and radius those corners there. And that's my wide flange. Can actually copy that and paste that as a block. That's not the most proper way to do it, but it'll work for now. You can actually create this as a proper right block if you are looking at building a library, but just for the exercise, just so we can go through this a little quicker, I'm just going to use that shortcut. So our building is 10 feet long, 6 feet wide, 12 foot high overall. So right now we're mainly just looking at the length and the width of our building. So 6 feet for width. Construction line, 72 inches long. Gonna copy this object. I want that. Snap there. And I want one more based off the midpoint, like so. And there's my width of my building. All right, and then we're going to do a side profile of this. And notice I'm just using all the geometry already given to me. I'm not doing extra work. There we go. So that's my side view. And we do need C channels, as I mentioned before. Right here. We're going to look up C6 by 13. So C6 by 13. Right here, C6 by 13. So my overall height, my D, is going to be 6. Oops, wrong layer. My BF is 2.157, right there in the bottom. So that's the base of the flange, right? So my TF, my web thickness itself, is 0.343. And my T, oh sorry, I mixed it up. My TF is 0.343. That is the wrong piece. That should be this piece here. There we go, my TW. My TW is 0.437. This is web thickness right here. And that's everything I need. So the thing that they don't truly show well is this curved out section here. The main thing is to get it looking fairly close. There are other sites that will actually show you that exact sizing, but just for our purposes, we don't need it that accurate. So let's do a fillet. And we can make that 0.605. Oops. Something like that. And there's my C channel, just like that. So, just gonna use that shortcut for the block. Move this to the end, and as I mentioned here, we want the first one flush to the outside, one along the center line, and then the additional evenly spaced 6 on the one side. So what that's going to look like is like so. It's actually hidden. One in the middle. One mirrored over there. And then this was where you had different options. You can choose to either array, or you can use a lot of copy and finding midpoints between objects. So, just so you guys can see what the array one looks like, I'm going to array this object here. I'm going to choose my path. It's going to be this path right here. And we're going to go with items. Oh, that's all right. Method. There we go. Measure. We went with items. No. Where's our guy here? Oh, come on, Crips. Going back over there. Alright, let's try that again. Okay. Something is not working out here. Okay, I'm gonna come back to that method later. So between that 2 points right here, it's my midpoint. So, copy that again. Last one. So I've done all that. I can just go take these 3, mirror that again. Done. So that's how I would lay out the C channels. For the top view, take those. Copy, and I've got my distance already set up. Those will be hidden. And this last one will be visible. Delete that. Copy these. And there's my top view. Copy this guy. Snap them down there so I can know. Actually, sorry, I should be copying all of them. Do you guys notice the general trend though? I'm always trying to use the geometry I've already built and set up. So I'm not always having to measure things out. I'm not doing things where I'm always having to calculate things. Once I've already figured out one set of geometry, I'm trying to use that across my design as much as possible. So this method only works well if you're very careful and accurate with what you've laid out previously. So you do have to be careful about that. So just do a copy now. I've got my distance set. Snap this to everything that should be visible. And one for the web if you want to be really accurate. Make that a hidden line. Once you've done that once, so actually I should take that back. Once I've done that once, I can go ahead and copy these to each one. I know those are a little bit backwards right now, but I'm going to fix that after. My original reference C channels there. And then now, I think I mentioned it to some of you, but maybe you didn't all catch this. There's a break command. So you can either break these or you can trim them. So I just want to show you how break works. Actually, I should do that over on this side here. So break, the first spot that you choose your line is the first part of your break point, as you can see. So I want to break it on this side, and that's visible. This is going to be broken there. So continue that on all the way through. Delete those. Trim these back. And just in case you guys didn't know, trim command works where you can actually choose your trimming border and then use your multi-selection. So you can trim more lines at one shot. So in this case, I can actually just use trim as well. Don't have to use break in that case. Where you would want to use break is in between here. Or, just to show you guys yet a different way to approach this, I can choose that line there to be my next trim point. Trim all these lines away. And copy all of these. From there to there. Oops, didn't get them all. Let's try that again. Any questions so far? Does this make sense? Like, is this the way that you guys approached it, or did you guys do things a little differently? Do you guys like this method a little bit better? So that's my top view done. So the one view that's missing, so I need to finish up this one here. So oops. So I know some of you guys were really confused about how to show your C channel, just because you weren't sure what's visible, what should be shown, and where. All right, done that, copy that over. And that part's done. So that would be one drawing I would leave alone, and then I would actually do a separate drawing over here with the finished plate. So this is gonna have, I believe I wrote down 1/4 inch plate. Where did I throw that down on? Okay, maybe it was missing. There should have said 1/4 inch plate. Might delete it by accident. So 1/4 inch plate to top. Floor. So I'll simple enough. 0.25. So. And there's my building frame, base frame. That's, I think that's where a lot of you guys kind of got to, right? Some of you guys maybe got a little bit further, but that took, what are we looking at? Maybe about half an hour to go through. So yes, you know, it's a little bit easier also once you're familiar with your steel shapes and just understanding how to build them out. So there's a little bit of that inexperience there. So there's no way I was expecting you guys to be flying through it at that kind of speed. But the main thing I just wanted to show you guys having a different perspective of how to approach this problem is maybe you guys were calculating things more, trying to figure out the math of it almost more, where you weren't using the power of AutoCAD and the shapes you've already generated to its strengths. So the other thing you can also do, is finish this off here. Yeah, actually a number of you guys got to the roof from what I remembered. So we'll just finish off this roof real quick here. So 4x4 by 1/4 inch. So my overall height as 6 feet. What are we looking at? Sorry, 12 feet. 12 feet overall height. So 144. So I'm just gonna grab another one of these frames, dump it over here. The base, 144, just so that I have my height reference. That's everything, including my roof line, which I still have to build out, and then that takes care of all of my my base height. So from here, I can start drawing things out. So we're going to use 4x4 HSS on this with 1/4 inch wall thickness. Just going to offset this top one by 4. Drop that down. Posts are 4 as well, so that part's done. Trim these back. Like so. And then my wall thickness, if I want to show that. Oops. Fix that one up later. Alright, there we go. There's my frame. And then to the front view, I'm just going to use this geometry again that I already have built up. I'm going to probably steal these posts here because I've already done them. Part's done. Now if we want to do a top view, just show our miters. can do that. This is where things might start to get a little bit messy. You may want to start choosing when to hide certain things, certain hidden lines. So maybe I won't need those on this part of the drawing. And maybe I don't want to show the hidden lines of my C channels. All right. So I'm going to make these all mitered. At 45s. Oh, that was the last ones. And there we go. So technically, since these are hidden away, shouldn't really see these. So I can just delete those or make those hidden. And there we go. That's my roof frame structure. Now if I want to show the roofing panels, as I mentioned to do last time, I can either make those all hidden or I can just delete them right out. And I mentioned they were going to be 12-inch panels with a 1-inch break down for each end. And they're going to be 0747 thickness, which is 14 gauge. I'll just show you guys that. 14 gauge. So 14 GA is a shorthand for gauge. So 14 gauge steel thickness. Lots of different sites for this. Let's just jump on this one here. Oh, maybe not. Let's go for the site here. There we go, 14 gauge. 0747 because we're looking at standard steel, not galvanized or aluminum. So offset 0747. Offset that. That's a little bit There's my wall panel. Oh, I think I might have made this a little too big. Yeah. So, no worries. 12, and I showed you that nice stretch command last time. Stretch. Take that base point, stretch it back, and everything fits. So there's my piece. So just so you guys know that shortcut. Again, I don't recommend using this for proper design. But just for quick modeling, right click and drag while holding the right button of the mouse. Click out somewhere, and it'll bring you up this option, paste as a block. So, as I mentioned, I want to have a 1-inch overlap. The edge here, so move that back 1 inch. And move that out 1 inch. Like so. Where's my error And there's my panel. So, actually, there's a few ways you can do this. You can either block that, you can array it, mirror this. Oops. So at some point, one of these panels, if I remember right, will not actually match up quite right. So a few options here. Got that little sliver now. So depending on how you want to have this, you can either make an odd shape panel right in the middle, or you can actually have everything shifted over. Where's my midpoint? Right there. Something's not looking right here. Something's a little bit off with my panels. That's all right. Just doing this for demo. Oops. And there's my roof. So to make this accurate, this is where I have to do a little bit extra work now. So we can either make everything hidden like that, again, this is the break command. Oh, that's looking really wonky. Something went wrong here. There we go. Anyways, so you continue doing that, cleaning up all your different layers and lines, and we'll call that part done. Move this down, using this as my reference. That's my first start point. Like so. And then you could actually technically break just this one model to show the bottom section right here to be hidden lines, and this visible, just to be truly accurate. So even though I did that quick save command as a block, you can actually go and ref edit it still. It's still a true block, so it does have all the features available for you to do that. And since I've lined that up there, I'm just going to use a line there so I can break this. Close. There you go. Copy that all the way through. And continue on. You can also array it, right? You know the size. You can also do the divide or measure method. So a few different ways to do that. And that's pretty much my whole building there. And do one more copy of this, just so I can show positioning. The whole point of this. There we go. So that was my approach at modeling this. Any questions? Does it make sense? Would this be faster, like some of those methods I approached this with? Do you think you guys could be able to use that during one of your designs? Yeah. So I'll give you guys a little bit more time. Go ahead and do some drawings, right? Because I don't know if you guys got a chance to actually start building some viewports. So if you haven't done that already, try doing that. So build up viewports. You want to have pretty much as many models as I have, if not some more actually, right? There might be a couple more you still have to build up from here, just to show all the different locations. What I want you guys to do is to actually have a drawing for each major component. And we'll go over detailing in the second half of the class, because we went through a little bit of it on our past exercise with the staircases, but this is actually a really good demonstration of an assembly that you have to properly detail with bill of materials and things like that. So try going ahead and doing that on your own for a little bit, and we'll go over it the second half. All right. Oh yeah, actually that's true. Sorry. Yeah, there should have been. Should have gone to the web. That's very right. I forgot to keep those. Actually, I'll do it on this one. So, really good point. There should be extensions to this web here.
No, only one side.
Right there.
Only one side.
Oops, missing a line.
Only one side. Another side is no. Only one side. You have the line only on one side.
No, this can be headline all the way through there, under the web.
No, another one.
Another one.
That one's not there. Yes.
No, that's right. Because it's the web and then the two edges of the C, right?
No, you cannot see the web. You can see the web here, but this one has been cut. This one has been cut. This one has been cut off. Only you can see here because it's been cut. This
Right.
is, yeah, that is big.
That's true. Yeah, that's true. Yeah. So, yeah, you're not really gonna see that one because, but you're gonna see the bottom. The bottom's still there. The bottom of the C is still there.
No,
Yeah. So, those are very minor details. It's so important, right? You do want to show that it does extend. To actually properly show these copes, you'd actually have to get really, really detailed. So what you would need to do is get that distance. Grab my C. Let's see here. sit down for this. Oh. It's over here. Take this down. Oops. Thickness of this. Like so. That. Actually, that'll work. Oops. There we go. And I should actually have one of these here. There we go. So that'll be your detailed view of a C channel that's either notched or coped away. So that is being prepared to actually slide into these I-beams. Technically I did it down here too, but if you just had to draw it from scratch, that's the way you would do it. That's your piece. Just crossed 7:45 here. If you guys want to take a quick 15-minute break, feel free to take a break there. Give your guys a break and stretch a little bit, and then come back and go ahead, finish up your model, try to get into the drawings, create those viewports, and start detailing them. Those of you online, feel free to share your screen. We can go over any kind of details, as far as what to annotate. And for everyone else here, if you have any questions of how we should be doing certain things, I'm also going to be demonstrating what to be detailing and how to do it. So we'll jump back on.